Okay, let's dive into this explainer. Today, we're looking at a literal masterclass in test suite optimization, coming straight from Ang's Notes on Haskell Programming, specifically Part 186. You know, if you write code, you write tests. Well, at least I really hope you do. But writing tests often comes with this massive, unavoidable headache, boilerplate. So we're going to explore how Ang dramatically reduces that redundant test code using some incredibly clever lambda assertions. Get ready, because we're about to trim some serious fat off our code bases.
I mean, really think about it for a second. Are you tired of repeating the exact same test blocks over and over? We've absolutely all been there. You're just staring at your screen, and you realize you've copy-pasted the exact same error handling logic for the 20th time across 5 different test files. It's incredibly frustrating, it clutters up your cognitive load, and quite frankly, it makes maintaining that test suite an absolute chore. This universal pain point, right here, is exactly where Ang's notes begin.
Section 1. The boilerplate problem. Let's look at exactly how this redundant test code actually manifests in our day-to-day work.
So in the original code Ang discusses, developers were basically forced into this tedious routine, dealing with an either resultant manual pattern matching every single time. You had to verify the right value, which, is your actual success data, but you also had to manually account for the left path, which is your error case. Doing this once, totally fine. But Ang noted that these exact case blocks were being repeated numerous times across several different test files. Imagine the sheer volume of redundant code generated just to say, hey, if this errors out, just fail the test. It's a massive waste of space, and more importantly, a waste of developer focus.
Section 2. Escaping manual pattern matching using assert right. Fortunately for us, there is a very, very elegant way out of this trap.
Now, what's really interesting here is the sheer difference in visual noise. Normally, you'd have a sprawling, messy case block, but instead, we see the implementation of a brand new helper function, Ang, brought into the test suite. Assert right alongside default args. By switching to the assert right helper function, the code automatically handles that pesky left error case entirely in the background. The messy manual matching, completely gone. It's replaced by a single, perfectly clean assertion. You literally don't have to write out the failure logic ever again, because the helper function just absorbs that entire burden for you. Absolute game changer, right?
Section 3. Decoding the alphabet soup of Haskell syntax. Now, if you're newer to functional programming, you might look at that incredibly concise snippet and feel, well, maybe a little intimidated. Let's break it down.
So, the crucial point is demystifying the syntax. Haskell is totally infamous for what developers jokingly call alphabet soup, a dense collection of symbols that can look like literal alien math. But it's actually incredibly logical once you see it. Take the backslash. It simply declares a lambda, which is just an anonymous function. Think of it as a quick throwaway function that doesn't even need a formal name because you're only using it right here, right now, to process the specific result.
And then we have the $sign. This is the infix function application operator. I know, it sounds highly technical, but its job is actually beautifully simple. It just dictates the order of operations. It essentially tells the compiler, hey, evaluate everything on the right side of this $sign first, and then apply it to the function on the left. It's just a slick syntactic trick used to clean up code and avoid deep, messy nesting.
And this brilliantly illustrates exactly how that $sign works in practice. If the version using the $sign operator feels like a bit too much alphabet soup for you, do a quick mental substitution. You can just replace that $sign operator with plain old parentheses wrapping our lambda function. They execute the exact same way. And Prody points this out specifically to ensure that the syntax doesn't get in the way of your understanding. Once you realize the $sign is really just an invisible set of parentheses, the snippet becomes instantly readable. We're literally just passing our anonymous function directly into our assert right helper.
Section 4. The clean code takeaway focusing on the happy path. Let's move to and see how this builds into a much larger, overarching philosophy for our test suites. This quote from Ang captures the absolute core of this entire exercise. It, quote, lets us focus only on the happy path. This is the real, crucial takeaway of our explainer today. By abstracting the repetitive arrow-checking logic into assert right, the developer's cognitive load is completely freed up. When you're writing a test, you shouldn't have to spend 80% of your keystrokes handling edge cases that fail the exact same way every single time. You should be testing what actually matters, the happy path. Does the function actually do what it's supposed to do? By cleaning up the boilerplate, your test suite transforms from a tedious obligation into a focused, highly readable document of your system's intended behavior. So I want to leave you with this final thought. Look at your current projects right now. Where are you writing the exact same error-handling boilerplate over and over again? Where is the hidden alphabet soup in your own test suites that you could refactor into a clean, reusable helper function today? Take a page out of Ang's book, find those redundant case blocks, build your own assertions, and get back to focusing exclusively on the happy path. Thank you so much for joining me for this explainer, and happy refactoring.